Hello students, hope you all must be fine. Today we'll study uniform circular motion in a easiest way. We know, as the name indicates, circular motion is motion of an object in a circular path, and uniform indicates speed of the object remain constant. That means speed does not change during the motion. Object will move in a circular path. Let it will start at position A. After certain time it will reach position B. Then it will move in that circular path and again reach at position A. During this motion it will complete one rotation. Once it reaches from A to B, it crosses some distance. As the path is circular, part of the circle it covers, that is arc. We say L is the arc length from A to B. Second point is, during this linear distance cover, it makes an angle theta at its center. That means for arc L, radius R, it makes an angle theta, and the relation, geometry relation of circle is theta is equal to L by R. This we need to remember, theta is equal to L by R. Now, next step is, we must know what is vector addition. Vector addition says, if two vectors are added and the resultant vector is, if two vectors are added, the resultant vector is the vector joining start point of first vector and end point of the second vector. Suppose vector A, this vector B, this is vector R is the resultant vector, then resultant vector will be the line joining start point of the first vector A and end point of the second vector B, or we write R is equal to A plus B. Here, once the object moves from A to B, position vector of point A is R1 and position vector of point B is R2. What is R1? Position vector of A. Position vector indicates what is the direction and length or distance of point A from origin O. Here position vector of B is the indicates the direction and distance of B from O. Distance of B is R, distance of A is also R from O. But direction of A from O is different from the direction of B from O. That means direction of R1 is different from direction of R2. R1 and R2 are the position vectors of position A and position B, or point A and point B. Now, when the object at point A, it has certain velocity is v1. Velocity is tangential to the circle. That means it is perpendicular to radius. Same way, velocity of the object at point B is again tangential to the circle and it is perpendicular to the radius. Now we find two triangles formed. One is R1, R2 and its resultant delta R. Delta R is the resultant of R1 and R2. Another triangle formed is V1, V2. That's velocity of the object at position A and velocity of the object at position B, and the resultant is delta V. Delta V becomes V2 minus V1. Delta R becomes R2 minus R1. Delta R becomes R2 minus R1. R1 is position vector of point A and R2 is position vector of point B. Delta R is the vector addition of R1 and R2. Same way, here what we did, to get the resultant vector, the direction of R1 is changed so that it follow the vector triangle law. Hence it became delta R is equal to R2 minus R1. Same way delta V became V2 minus V1. Now we'll go to acceleration, because here the velocity has changed for different position of the objects, because though speed is constant, that's why we told it is uniform motion. Speed is the magnitude of velocity of the objects. At each point, magnitude of the velocity remain constant, whereas velocity changed due to direction of the velocity change. Here at position A, object has velocity v1 and its direction is tangent to the circle at point A. And at point B, direction of velocity of same object is tangent to the circle at point B, and both have different directions. Hence, direction changed. Due to change in direction, velocity also changed. Acceleration is the change in velocity by time duration. That is, v2 minus v1 is the change in velocity delta v by t. We know acceleration is rate of change of velocity or change in velocity by time, let's say acceleration is equal to delta v by t. This is like equation 1. Now let us find out delta v from these two triangles. Once we compare these two triangles, we find two triangles are similar, hence delta r by or delta v by delta r becomes side v1 by side r1. We know magnitude of v1 is v and magnitude of r1 is r2 is equal to r. Everywhere magnitude of radius r1, r2 is radius of the circle r, and magnitude of velocity every position v1, v2 and all is v. Now delta v by delta r became v by r, hence delta v became v by r times delta r. Let it is the equation 2. Now again just find out what is value of acceleration. We find v by r in times delta r by t. Acceleration became v by r times delta r by t, because delta v became v by r into delta r, then divided by t, then acceleration became v by r times delta r by t, or v by r into, here when the time duration becomes small, this delta r also decreases, and at certain very small time duration we find this arc or this arc and delta r will be almost same. That means in that case it will be our distance during that time the object has covered. When time has reduced and time became delta t, where delta t tends to 0, here theta also became so small and L becomes, the arc becomes a straight line, that becomes the distance, linear distance, that becomes the linear distance S. And here delta r becomes S due to time became so small, tends to 0, then delta r, the straight line or the resultant vector of r1, r2 becomes our, likewise we can say it becomes so small that this and the circle arc becomes almost similar and taken as delta r is equal to S. Delta r is equal to L is equal to S. Now S is the distance. We find a delta r by t is equal to S by t, that is our velocity v. Now placing this one, suppose this is our equation 3, we get acceleration is equal to v by r into S by t, or v by r into v is equal to v square by r, or a is equal to v square by r. Equation becomes 2, 4. Now once we go to geometry of the circle, we find theta is equal to L by r, and theta is here is angular speed, or once direction is specified it becomes angular velocity. Now we consider theta by t, direction not considered. Then it became angular distance, and theta by t became angular. When theta became angular distance, theta by t became angular speed. It's omega. It became, once we put value of theta is s by r, then omega became s by rt, or s by r is v, then it becomes omega is equal to v by r, or v is equal to omega r. It is equation 5. Now from this we found that acceleration is v square r, or we can place value of v is equal to omega r, then acceleration will be omega r whole square by r. Summarizing what you have studied till now, to find out the value of A, because main goal of this topic, uniform circular motion, is how to find out the acceleration. Now acceleration we know is rate of change of velocity. Then to get this acceleration we have to find out its magnitude and its direction. To find magnitude, we have covered vector addition, where the position vectors r1 and r2 are added, and we found out the resultant vector delta r. Vector v1 and v2 are added, and we found the resultant vector delta v. We have used circle geometric formula, theta is equal to L by r. When L becomes very small, it becomes S, or theta becomes S by r. Then angular velocity formula is omega theta by t. In that case, theta is angular displacement. Now once we have considered the direction, we have not considered direction, we are considering only magnitude, we can say theta is the angular distance and omega is the angular speed. Then W is equal, omega is equal to theta by t, or theta is equal to S by r, then omega is equal to S by rt or V by r. From this we found the first equation of this uniform circular motion is V is equal to omega r. That the relation between linear speed or velocity and angular speed or velocity. V is the magnitude of linear velocity and omega is the magnitude of angular velocity. Now we say it is angular speed and this is the linear speed. From this, now we found that acceleration is delta v by t, which became v square by r or omega square into r. Now to find out the direction of AC, already we have studied vector addition of velocity v1, v2 and resultant velocity is delta v, and the resultant vector of position vectors r1, r2 is delta r. This direction of this delta v is perpendicular to delta r. That means it is towards center and along the radius. This acceleration direction is also along the direction of change in velocity of delta v. Hence, the direction of A is along the radius towards center. That's why the name of this acceleration became centripetal. Centripetal acceleration, or we say acceleration is centripetal acceleration, that is towards center along the radius. It is radial and center towards center. That's the centripetal acceleration. With this, we have covered our uniform circular motion, in which we have used what is the formula for acceleration, what is the angular relation with the linear, with the vector addition, what is the circle geometric formula, and resultant one we got is v is equal to omega r and AC is equal to v square by r, or AC is equal to omega square